On to our next speaker, our keynote 2, Drive the Future with AI-Enabled Testing. And this will be presented by Ms. Mayuri Darabastu. She's the Manager of Quality Engineering, Practice Lead, Robotic Process Automation, Innominds. So in this presentation, Mayuri will share the Innominds journey to build AI QEP platform and how it can address the challenges in software test life cycle. So let's give her a warm round of applause and welcome Ms. Mayuri on stage. Thank you.
Good morning, everyone. It has been a very great experience being part of this conference. This is my first time at STC, but I'm thoroughly enjoying it. And we all have a very good, insightful sessions yesterday. Looking forward for a couple of more sessions today. So, getting started, so today we will be discussing and sharing thoughts about AI-driven testing, which is definitely a buzzword in this conference. So since the beginning of the conference, we all have been talking about AI, and I would extend it by providing an implementation solution, which we have just embarked at Innominds. So before we get started, let's talk more about the software testing transformation. The transformation I'm talking about, which happened 20 years ago or maybe 2 decades ago. So when we talk about the early 90s, wherein the SDLCs were only the integration part of testing was only the development areas. So basically, the testing was taking the integral part of the development, and with that said, the testing did not have an entity, it has no voice, and we never had a formal testing, right? So it was just part and parcel of the entire development process that was happening. So in mid around 90s, I can say, owing to the market dynamics, the organization started seeking to understand the need of specific or defined testing efforts. So in order to embark that, or in order to ensure that we embrace the software development life cycle, we have actually started to embrace the software development life cycle within the SDLC. So with the evolution of the software development life cycle, definitely it had its own distinct features, like its own planning, design, execution, and the closure phases, like we all know. So this change have driven the companies to invest more and more into the testing organization. So we have seen building of testing as a center of excellence now. So testing has again dramatically transformed itself into a center of excellence, wherein it has spread across various domains. Also, when you see, we have embarked so many journeys, starting with test automation, getting into cognitive process automation, which is again a buzzword, robotic process automation, which is my job, which I do at Innominds, and also enabling the cognitive bots by bundling the RPA with AI. So that's again the next level of process automation. So, the testing COEs, as I was mentioning, are taking a shape wherein the various other factors started gaining more and more importance, such as the non-functional testing, I can say the exploratory testing, and different processes which basically enable the testing also have started evolving. And I can say that the CEOs or the Center of Excellence were established as a horizontal functions in every organization to support the business unit needs. So what do you mean by an horizontal function? So earlier when we are talking about testing, which I just stated, there was no testing or a minimal testing. Right now, every organization have a separate practice called QE or QA, wherein we embrace testing starting from manual to automation, RPA, and now it is AI-driven testing as well. So this is the journey. And in the meantime, as the CEOs also started, we started equipping ourselves to enable and support the evolving process of Agile. Now, as you know, Agile, it is dynamic, it changes every day, and that brings a question again, that where do we start from? So the practices like shift left, shift right, gained more importance and significance because few of the people have already stated that testing is needed in the early stages because we start from the initial requirement phase, and the requirement itself, if they are buggy and if at all the defects are available in the requirements, then there is no point in further proceeding with the testing, right? So again, also there was another shift, that is a shift right, which was a shift right to actually capture the customer feedback rightly. So post production, if at all there is any bug that is coming up, how do we handle it? How do we cater to it? And then it went into shift deep, which is again AI and ML, as we all know. So it's all about deep learning. So let's talk more about the challenges here. So as we all are the testers here, if I'm not wrong, so we all know the challenges in the testing industry, right? So with the advent of agile and with the advent of complex software development life cycles, definitely we all are under pressure to deliver faster, to deliver a quality product, and definitely deliver under a timeline, right? So the testers also have to quickly react to a defect, understand its impact, analyze the defect, and then provide the feedback immediately to the developers in order to cater to this complicated life cycles, right? So having that said, usually in this stressful days, so usually we see that every day there is a new software launch, every day there is a new product launch, wherein the testers are under immense pressure, like, okay, what are the defect prone areas, what are the heat maps, are we really doing the right testing, are we really doing the right regression, are we actually focusing on the right areas where we find the defects? So all these things need to be considered, right? So there we actually enabled AI. So I'll actually go through a couple of challenges before I take you through the AI driven testing. So here are a couple of challenges. So releases earlier, at least before 3 or 4 years, which we can talk about, the releases used to be once in a month maybe, but now the trend has changed. Every week there is a release, every hour, maybe a couple of companies are also having releases multiple times in an hour. So how do we cater to this continuous testing? So we also find that all the updates as part of Agile are factored every single day. So today you have a requirement, tomorrow again there would be an enhancement for the requirement, and this is a continuous journey, right? And also the businesses are struggling with 3 important things. First one is definitely a superior software quality. Second one is a faster time to market. And the third one is reduction of the cost, right? So these are the 3 main things any organization would look at. So considering this, by efficiently managing couple of factors like code drops, your application downtimes, and your defects, and then your code quality, these things can definitely result in invaluable opportunities. However, we do not have control over this because of all these challenges. So the challenges that you see here are the day-to-day shrinking test life cycles. So as I said, the shortened life cycles, which are like 1-week sprints or maybe 2-week sprints, wherein we target for a couple of user stories and rush to finish off them. And then also a skilled person or a skilled tester is really important here to also adhere to the shrinking test life cycles. And then again we have the wider test coverage in a minimal time. So whenever we talk to any prospect or a client, what would be the first thing any customer would ask for? Test coverage, right? So if I am giving you a project, if I am giving you an application to test, what would be the coverage? How much part of coverage you are providing as per automation, as per API testing, as per performance, or if at all it's a manual. And then talking about disruptive technologies, covering critical test cases at early stages. So how do we understand that this particular test case is critical? So when, for the very first time when you're doing the application testing, how do you judge and predict that, okay, this area, so usually in a normal scenario, being a tester myself for the last 10 years. So when you are working with an application which is an agile, you start up from the scratch, right? You work on a user story which you don't know where exactly it's going to be implemented, right? In that scenario, if you at all you find a defect, what would be the prediction of the criticality of the defect? Let's say you just tagged it some severity. How do you say that the severity that you have tagged is right? Okay, if at all you're a subject matter expert, being in the industry for 10 years and you know that, okay, this domain or this application, in this application, this functionality would refer to this, probably you may assign a right severity. If not, if I'm talking to a fresher or if I'm talking to a guy who just started his testing experience, what is the criteria on which you assign the severity rightly for an application in Agile? Again, cost optimization, as I said, everybody wants a quality product with a minimal cost. That's the tagline. So with the advent of Selenium, everybody started looking for an open source automation, right? So even you have a better features in a commercial tools, people say, I need an automation, because they're looking at cost optimization. And then we are talking about complex infrastructures wherein you have microservices, the API testings, and the other RESTful services that we test, high tool cost, ambiguous requirement, and high capex with OPEX. Capex is nothing but the capital expenditure versus your operational expenditure. Any business would look at this comparison wherein if at all the capital expenditure increases or is more than the operational expenditure, definitely that's a challenge, right? And then increased TCO, which is test cost ownership, huge backlog of test cases with the advent of Agile again, ever-changing technology, and defects in production environment. So these are a couple of challenges that we are talking about here. And let's see what can we do better here, being a tester. So we all know various flavors of testing. So now I'm going to introduce a new kind of testing. Not just identifying a challenge, we should start working towards a solution, right? Now, how do we work towards a solution? So as we were just talking, most of the organizations are now embracing and evangelizing AI, ML, and deep learning. What exactly are these? What are we talking about AI, ML, and deep learning? Any answers? Any predictions? Yeah? Have you ever heard about a term called predictive analytics? You all know what analytics mean, right? In a general English verbiage. So what are the predictive analytics? Sorry? Okay. And? So nobody is aware about predictive analytics? Absolutely. So over few years, AI and ML have become the mainstream. So I don't think so, if at all I ask somebody in 2016 about what do you do with artificial intelligence or machine learning, probably out of 100 people, only 10 people have that awareness, right? But in the recent, at least last 6 to 8 months, with the emergence of RPA, definitely AI has got more and more significance, wherein we are talking more about cognitive bots, bots which can take judgmental decisions on their own, bots which can mimic the humans, bots which can actually think beyond the humans is what we are talking about, right? So owing to Innominds' experience in AI and ML-leading analytic data platform, we have our own product which is called as iFusion. So iFusion is all about AI and ML. So as we already got the expertise, as we already have the knowledge of analytics, we have started embarking our journey into integrating AI with testing. Now let's see how the implementation part goes. So Innominds has built AI, which is artificial intelligence powered by quality engineering platform. Okay, here the artificial intelligence is what I'll explain in the further slides when I show you the implementation part of it. However, this particular AI applies the shift deep technologies to predict the failures and unearth the potential defects that may arise ahead of the releases. So just now when we were talking about the challenges, what were we talking? We are rushing through the releases, we are rushing through the test life cycles. What can we do better that we can predict the defects before we actually get to the releases? So let's see how the implementation part goes here. So let's start with all the services that are offered as part of AI. So as it's our homegrown platform, we have services like test coverage, prioritization and optimization. I will explain you each and every service going forward in the next slides. And it's predictive test management, as the other gentleman was talking about, and defect root cause analysis, intelligent dashboards, customer sentiment analyzer and defect prediction. Any idea about customer sentiments? How many of you use Amazon or Flipkart apps? I think everybody in this hall, right? So have you ever bought a product and gave reviews on the product? Like your mobile phones or any item. Did you ever? Yes? So what kind of reviews do you give? Whether it's good, bad, worst? Based on the product, based on what your feedback was, right? So that is where basically the clients would look at the customer or the user satisfaction, right? The end user satisfaction. We'll go in detail to it. However, first let me talk about the key requirement here for the AI or equip. So we have named this as equip. It is AI driven or powered quality engineering platform. We shortly call it as equip. So equip is enablement of AI towards testing, right? So when we talk about equip here, we will talk about the key requirement of AI. Now what's the key requirement of AI? You should have historical data in order to do the predictions, right? So data is the key. So we start with understanding and analyzing the data first, right? So we get all the data, we understand and analyze the data, and then we further categorize it into smart assets. The smart assets here are any logs, your event logs, your performance log. So being a tester in your day-to-day testing life, you end up looking at various logs. You end up with defects, test cases, traceability matrix, any event logs, any application crash logs, or any performance metrics, any API related metrics. There is huge, humongous data in the testing, right? So all the data is being tracked and targeted towards building the tests. So I'll tell you in detail how exactly that happens. But before that, let me tell you what exactly AI does. So AI basically optimizes the test suites. It optimizes the test coverage. It also ensures the overall testing efforts are optimized. And also it identifies the high risk vulnerabilities that can be evolved from any module, test case or even an application. So going further into it, let's understand what data are we talking about. So as I mentioned, we would gather the data, right? So data comes from where? So if at all we have to enable the data rules, which are the main fuel for AI, we have to look at the application logs, your database logs and your app server logs. Here you will get the data which is required to create the data rules for the prediction, right? And how do we come up with the business rules for that particular scenario? So we basically take event logs, your performance monitoring logs. So nowadays every application would have a performance monitoring app, right? That app would generate the logs. All those logs would be required for us to understand the business rules. And then the analytical engine, which is the main engine or the brain. So this analytical engine should be fed with all the information. The data can be humongous. So how well you feed the data, that well you receive the predictions. Let's say you're giving 1-2 years of data, the predictions may not be that prompt. But if at all you're giving like 10 years or 5 years of data, surely you will be able to get a better prediction, right? And then you also have your text analytics, which can be derived from your incident logs. So as I've mentioned that this is a pilot phase and we have just embarked the journey, we have enabled the equip from the manual injections of the data sets. As I told you, we already have a product called iFusion, where when we do the analytics, we actually infuse those data into equip. But going forward, as we are into phase 2 of this project, we are trying to build a plugin which will be enabled on all the test management and the CI tools, and then you will be able to automatically predict the analytics without, without doing anything additional. So while you do your testing, the predictive analytics automatically takes place, right? So that is in progress. We'll surely share you the news shortly. So any questions here? Yep. It cannot be a production data for sure. It can be any sets of data. So we have also developed, so you will hear from me in the next slides how we develop the data as well. So usually when we are talking with a client that they want to do a predictive analytics, they would not be comfortable enough to share the production data or the confidential data, right? So there should be a way to break through and still continue with testing. So we have developed a test data generator and optimizer, which will actually generate the positive, negative, and any neutral data. And this also is built on an algorithm, right? So this has also been done by AI. So this test case generator is backed up with AI, which understands what kind of data it needs, and then it automatically creates the data and injects the data, right? This is a case when there is no data. Okay, now coming to the test coverage, prioritization, optimization. So as I have told you about the services in the previous slide, I would be briefing about what exactly we do for each of these services. Now, what is test coverage, prioritization, and optimization? We all know, being testers, that the test coverage is the prime goal of any customer. So we basically focus on testing what is right than doing an exhaustive testing. Now, what is testing right? Sorry? Okay, so I'll give you a quick example. I have some 250 test cases, right? I have A, B, C, D, E modules. Now, these 250 test cases are spread across various modules, right? I have module A with 60 test cases, module B with some 80 test cases, C with 15 test cases, D with some 100 test cases, and E with some odd number of test cases. Now, if I have to do the right kind of testing, what would be my first approach? I'll have to pick the traceability matrix, understand what is the defect prone areas. So we all understand heat maps, right? The areas which are defect prone are the areas which are critical and which are the right ones to pick for the testing, right? So such kind of predictions, such kind of heat maps would be generated by AI, which will enable the quality engineers to select the right set of test cases to enable the execution. We will go further and discuss how exactly this happens. So right now, as we are talking about the test coverage, prioritization, and optimization, AI deep insights weed out the human errors. It increases the traceability and it definitely reduces the duplicates, also empowering the quality engineers to get the right test cases and also to get the early detection of the defects. So as we are already providing the prioritization and the heat maps, the early detection of the defects would be enabled. We'll also show you the implementation part of it going forward. And next one is test scenario mining. What is test scenario mining? So it is basically the behavior, the customer behavior, the usage patterns, the customer sentiments, right? So what again defines a pattern? Let's say there is an application and probably like today is a Thanksgiving day. What happens to my data? I would have already built models that, okay, these are the frequent items that are purchased, or these are the items which are bought together, or these are the items that pops up in the relevant items. But once there is a huge load on the application, would that still work? Does that pattern still remain the same, or does that still remain valid? Right? So basically this AI can equip identifying the test scenarios, test patterns based on customer behavior and also customer sentiments and also the usage patterns. So basically the benefits that we can derive by using the equip enabled testing is that you can plan new scenarios based on the injections, and you can also plan better testing and better strategies. So I'll tell you how by giving an example. You have been working on an application which is AI driven or AI enabled, but then you got another small application integrated into the entire slot, right? Now what happens? The data patterns which were generated earlier would no more be valid. What we have to do in order to AI to understand the new patterns, we will have to enable the AI to, for the self-learning and self-training. So what is self-healing? Any idea? Have you ever heard about self-healing, self-training bots? I'm again going back to my core skill, RPA, but then yeah. What is self-healing? It is automating an automation. So basically when we talk about self-healing, the application or the automation should be in a position to heal itself whenever there is a breakage or a violation, right? We'll see how exactly even that would happen in the demonstration. And going forward, we would deal with the defect RCA, which is the normal defect root cause analysis. So post-production, if you are getting any defects, the first thing the manager would say is, go back and do your root cause analysis. Am I right? So why do we do the root cause analysis? What is the specific reason in doing root cause analysis? To find the probability, right? So to understand the root, why the defect has occurred. Does that mean that every time it's a slippage from the tester? It may or may not be right. So there can be n number of reasons that may contribute to the root cause analysis, and AI would help robust root cause analysis. We will show you exactly how it would detect the similarities with the earlier occurred defects. And then defect prediction and defect test data generation I've already covered. So intelligent dashboards we will see in the practical implementation. I will not cover much about here. So what do we require to adopt AI in testing? So you all must be thinking, what should we do then? Right? So first core need is defining the use cases. Where exactly does this AI fit? Actually, it fits in all the scenarios. Whatever a human can do can be done by this AI as well, which is a machine learning. So gathering the data to train the ML. So as I've just mentioned, we need to gather the information, we need to source the information, and also we need to correlate the information. So when we are talking about data sets, a data can be a log, a data can be a defect, it can be a test case, it can be a performance related log, right? We will have to get the correlation or the traceability between these elements before getting into the next levels. So we gather the information and we train the ML algorithms. We will talk about the algorithms as well. And then we perform the basic data exploration. Basic data exploration are similar to our positive test cases or positive flows or happy path flows we talk about. And then we define a model building the methodology. As we do, we first start the testing with the happy flows, right? Even here for the ML, we first start building the algorithms with the positive node and defining a model validation and then conducting a pilot, verifying similar to what we do in testing, gradually implementing AI. So why are we saying that we are gradually implementing? So I'll take the same example which Mr. Avinash has taken yesterday, comparing apples to apples, apples to orange. Let's say for example, you have some material over here, this is a wooden stand or something. Now because I'm a human, I understand that this is made of wood, this is not transparent, and I understand that this is strong enough. Now how do I train a algorithm to understand that it's a wood? I have to define the properties, right? And I have to expose the AI to different scenarios wherein I have to give both positive and negative. I'll say this is a glass, it has to revert back saying no, the properties does not match, it's a wood, right? That is how you test. It is all similar to what we do in testing, a little extra or a little more into deep learning that wherein we get into ML and AI. So what are the benefits that we have reaped after deploying this pilot equip? We have personally tested it on all the existing customer accounts, and we had a very, very positive response from all of the customers stating that this is a humongous change in the predictions that they have done till date. However, we are waiting to deploy our phase 2, wherein we are getting a plugin wherein directly when you integrate it with your test management tool or your CI/CD tool, it will directly start predicting the analytics. So we have benefited getting improved accuracy. So we have got more accurate results because we have trained the bots in a robust way, and we are going beyond the limitations for traditional testing by giving away all the challenges, and then 30 to 40% of optimization increase with the improvement of test coverage. So as I have mentioned earlier, there will be an optimal test coverage, because why we will see later. Enhance quality by 20 to 40%, and then 25 to 35% in total effort. So what do we reap out of it? Again, coming back to the same, faster time to market, right? That is the challenge we have been talking about since the beginning. So also let's talk about the challenges that we have adopted in AI-driven testing. So we were talking about different types of data, right? And this different types of data comes from different diversified tools, right? So that's again a challenge. And then the data cannot be a log or a test case every time. The data can be a gesture, a data can be a chat, a data can be a voice, because we are talking about AI. So that again poses another challenge, and also the data is ever changing, right? You keep on adding more data into it and more data types into it, and the massive volume of data is also another challenge. Skill here is another challenge that we have faced. So we require two different skill sets here, because Innominds being a tech savvy company wherein we have the analytics, data science engineers and the SMEs, we were able to overcome this, but definitely we need some data science knowledge as well as the subject matter expert domain knowledge in order to embark on this. And if at all we do not have data, there is no question of protection. And the other huge question which everybody has is, how much of data do we need? So we wanted to do a prediction, right? And we wanted the predictions to be accurate. How much data is needed? So that actually depends on the quality of the data that we are supplying and also the volume of the data. Now, let me actually show you the implementation part of it. Intelligent dashboard that we were talking about. So we have been discussing about the predictive test management, the QA sentiment analytics, the defective resolution. All the QA services or all the equipped enabled services would actually be demonstrated here. So let's first see the first analytic that we wanted to talk here, which is predictive test management. The video is a little quick, so I'll be pausing every now and then. So here you see the predictive test management AI. So let me pause this. So this is the predictive test management. So what we did here is we have actually supplied a huge data of the test management tool to this particular interface, right? So now, as I've told you, we are currently uploading the data manually, but we are working on a solution which takes the data automatically. You need not do anything, right? So we are currently uploading the data. So once the data is uploaded, it basically processes and treats the data. So it cleanses the data, and then now it is clicking on the model selections. So what are the models? So before we get in there, let's understand more about models. What are the data patterns and models that we are talking about? So let me give you a quick example. So using the prior execution history, here we are basically trying to derive a model. Model is nothing but a pattern, I can say. It's a prototype which actually resembles or mimics the exact data. So we are creating a model selection here, and then we basically understand what if analysis here. So once we derive the models and once we publish the insights, you will see how exactly we can analyze the what ifs, and you can also provide the early predictions of the data as well, and you will be able to do the prescriptive suggestions and also provide the remedial issues as well. Let me play it once again. And now it is identifying the model and it's validating. So because the data is huge, it is taking a little longer to identify the model. So first of all, as we are seeing this model, I'll also give you a couple of details about the algorithms that we have used in generating this particular AI. So how many of you are aware about ARIMA here, the ARIMA algorithm? Any idea or any insights into it? So ARIMA is an auto-regressive integrated moving average. It is an algorithm, and here we have used the seasonal ARIMA, which actually can take any data patterns, inject any data patterns and can act to it. And upon using a seasonal ARIMA algorithm, we have also used halt winter, which is another kind of algorithm. Both of these algorithms are time series related algorithms. So now that the model is built, let's check the insights that have been. So you can see the insights here, right? Let me take it back for your reference and pause it here. So we have fed this data. So we have fed the data from 2015 to 2018. So we have taken this data from a defect management tool. We have simply injected and fed the data to the analytics reader, and this reader itself has trained the algorithm. It has self-trained itself to understand how many defects have occurred on which month, what are the predictions, and based on that, the orange color graph that you see on the right hand side are the predictions that are made. And here we also have given some details as to what departments data have we given and what is the forecast data. So this particular ARIMA algorithm has used the data. It has forecasted like how many defects may occur in the month of October, November, December, and going forward. It can also give you the insights for a year or more, but let me get into the next test here. So as you can see, it is rolling up and down and showing you the complete stats here. Okay, and the next one is customer sentiment on defects. So I was talking about the e-commerce application just now, right? So wherein we have taken an application from the internet, we have used an open source web scraper to scrape the data from it, and then we have fed the data to the AI algorithm, and then it has generated the stats for us. Let's see the predictions here, how exactly the customer reacted to the product. So here we have used NLTK, which is Natural Language Toolkit, and then it is processing the data here for you. So we will be able to generate these sentiments by function, by UI, by design, by performance, or an application related issue. Here are the stats. So it has taken the feed from the internet, from the web scraping, and then it has used AI to generate all the needed analytics. Yeah, and the next one is auto severity of defect. So before I started demonstrating the demo, I posed a question. So how are you deciding the severity? If you are having a scenario wherein you have multiple testers working on a single application and all of them are not co-located and all of them are not equally skilled, how you ensure that the right severity is being assigned to a defect? So here we have used another algorithm wherein based on the previous data or based on the previous history, it takes the so here I am taking the severity as a source. We can take any target or the text variable to process and treat it, and we have used random forest algorithm here to process the data. So here you see the auto severity is now been assigned. We will also show you on what basis the auto severity is assigned, on for what all defects the severity has been assigned. So you see that the major, minor, cosmetic and crash data loss issues have been already detected. It also mentioned the defect ID. Now how did this algorithm understand that this defect has this severity? It is only based on the previous data or the previous validation that have been done, and it also empowers the testing by using its own artificial intelligence skills and machine learning skills to understand the problem and tag the problem based on the severity. See, the next one will answer your question. Yep, I'm done. So this is basically a descriptive analytics that we have done for a client just to showcase how exactly it looks like. It is similar to any dashboard on a test management tool, and I'll get back to your question. Give me a moment. So this is a defective resolution algorithm that we have built. So it will basically understand the error. So right now it has selected an error. Now it will search for an error, and then it will also understand the incident solution. It will also have the similarity assigned to it. So like, let's say for example, this has 0.621 solution similarity to it, and it will also describe how exactly this solution was resolved earlier, and it will pick the nearest number like 0.99% similarity and then provide the optimal solution. Yeah, so again coming back to the challenges, answering your question, if the data is not right and if the the bot is not trained properly, there may be definitely a challenge, right? So we also, in order to avoid that, we have another algorithm which is seasonal ARIMA, which I have mentioned, which will actually understand the logic and train that bot as well, right? So I will end the session here. Thank you all for your patient listening and appreciate your time. Should you have any questions, please reach out to me over a coffee break. I am happy to explain you in detail. Thank you so much.
Another great presentation by Ms. Mayuri Darabastu. Thank you very much.